Problems on system response. So first problem, this type of problem was asked for 6 marks in exam. So first problem, impulse response of RC circuit is given as h of t is equal to 1 by RC e raised to minus t by RC u of t. So find the unit step response of circuit. Find unit step response of circuit. So solution for this, impulse response is the response of circuit when applied input is unit impulse, that is delta t. So we write here impulse response is response of circuit when applied input is unit impulse delta of t and unit step response means output of system when applied input is u of t. Okay, now the step response is related to impulse response. We write here now step response is related to impulse response as s of t is equal to integration infinity to t h of tau d tau. But what is given here? What is given? Given that h of t is equal to 1 by RC e raised to minus t by RC u of t. Therefore, h of tau is equal to 1 by RC to minus t is replaced by tau. Due to multiplication of u of tau, the limits of integration will be from 0 to t. So it is equal to integration 0 to t 1 by RC. So we will solve it 1 by RC into bracket So this is the value of S of t. That is, it is the unit step response of the given circuit. So this problem was asked for the 6 marks in exam. Next problem. Second problem. Find impulse response of following system. So first is y of n is equal to 1 by 4 k goes from 0 to 3 x of n minus k. Now represent answer in terms of un. We write here in terms of u of n, and second is y of t minus infinity to t x of lambda to t lambda. So first is solution for this. Now what is given? Y of n is equal to 1 by 4 k goes from 0 to 3 x of n minus k. Now impulse response of system. Impulse response of system h of n means output of system when applied input is xn equal to delta n. So hn is equal to 1 by 4 summation k goes from 0 to 3 delta of n minus k. So hn is equal to 1 by 4 delta n plus so we expand this summation. Now we will draw the diagram for this. So it is hn, it is n, h of n, so it is 1/4 of n equal to 0, 1, 2, 3. Okay, so we can represent this hn signal as it is 1/4, 1/4, and from it is now in terms of unit step we can represent it. Here we write in terms of unit step it can be expressed as h of n is equal to 1/4 of un minus u of n minus 3. Now the second problem in this, what is given? Given is y of t is integration minus infinity to infinity x of lambda d lambda. Now we have to consider the convolution of xt and ut. So consider convolution of x of t and u of t using definition of convolution. So x of t into u of t minus infinity to infinity x of lambda u of t minus lambda d lambda. Therefore x of t into u of t minus infinity to infinity x of lambda u of minus lambda plus d d lambda. But this term u of minus lambda plus d is folded and delayed unit step which exists from minus infinity to t. Therefore x of t into u of t, it is minus infinity to t, x of lambda into d lambda. So the convolution is denoted by x of t to h of t, and therefore impulse response is equal to h of t is equal to u of t. This problem was also asked for the 6 mark. Next problem, third problem. Find unit step response of the system whose impulse response is first delta of n plus 2 plus delta of n minus 3 and second u of n. Now in that first one, So what is given? Given is h of n is equal to delta of n plus 2 plus delta of n minus 3. So this is given. Now step response we write here. Now step response means output of system when applied input is unit step, that means xn is equal to u of n. So now y of n is equal to x of n into h of n. Therefore y of n is equal to u of n into delta n plus 2 plus delta of n minus 3. So yn is equal to u of n minus 2, so u of n minus 3. Now the second problem. Now what is given? Given is that h of n is equal to u of n is given. Therefore y of n is equal to un into u of n. Now here h of k is uk and x of k is uk. We consider these two different terms. So according to the definition of convolution, we can write yn equal to summation k goes from minus infinity to infinity x of k h of n minus k. Now here h of n minus k is equal to u of n minus k, which is equal to u of minus k plus n. So yn is equal to summation k goes from minus infinity to infinity uk u of minus k plus n. Now range of summation will be 0 to n. Therefore yn equal to summation k goes from 0 to n, 1 raised to k, which is equal to n plus 1. Now next problem. Fourth problem. Find step response of given LTI system. So given system is h of t is equal to t x of t plus 1 u of t. So first we write what is given. Given is that ht equal to x of t plus 1 u of t. Now step response is output of system when applied input is unit step, that is x of t is equal to u of t. Therefore x of t plus 1 is equal to u of t plus 1. So h of t is equal to t u of t plus 1 u of t. Now step response is given by s of t integration minus infinity to t h of tau d tau. So it is minus infinity to infinity, t is replaced by tau plus 1. Now the multiplication of u of tau plus 1 it gives the range from it is equal to minus 1 to infinity. Therefore s of t equal to integration minus 1 to t, so it is equal to tau square by 2 minus 1 to t. Therefore s of tau is equal to t square by 2 minus. Therefore s of t is equal to t. So this is the step response of given LTI system. Now the next problem. Next problem. Test the stability of LTI system whose impulse response are first h of t is equal to e raised to minus 5u out of t, and second h of t is equal to e raised to 4t u of t. Now we will solve first problem first. Now according to condition of stability. From minus infinity to infinity, given h of t is equal to e raised to minus 5. Therefore, minus infinity to infinity, we take the integration from minus infinity to infinity. So we solve it. It is from minus infinity to 0. And it is from 0 to infinity. Now we solve this integration. So output is bounded. So here system is stable. Okay. Now the second problem in this. So what is given? Given is h of t is equal to e raised to 4t u of t. So we take integration from minus infinity to infinity h of t dt. So it is minus infinity to infinity e raised to 4t dt. So it is integration 0 to infinity e raised to 4t dt. So this is the answer. Now the next problem. Now this problem was asked for 8 marks in exam. Find step response. Find step response of first order recursive system with impulse response h of n is equal to 1 by 3 raised to n u of n. So the step response of dt system is given by dt system is yn is equal to summation goes from to minus infinity to infinity h of k. This is our equation number 1. So now what is given? Given is that h of n is equal to 1/3 of raised to n u of n. So h of k is equal to 1, n is replaced by k. So this is the equation number 2. Now due to multiplication by u of k, limits in equation, limits is of k from 0 to n. So we can write this equation yn equal to summation goes from k equal to 0 to n 1/3 of k. Now we have standard summation formula. So it is summation n equal to n1 to n2 a raised to n, standard formula of summation. So it is a raised to n1 minus a raised to n2 plus 1 divided by 1 minus a. Now this value is for a not equal to 1. And next n2 minus n1 plus 1, this value is for a is equal to 1. Now here a is equal to 1/3, n1 is 0 and n2 is n. Therefore yn is equal to 1/3 raised to 0 minus 1/3 n plus 1 divided by 1 minus 1/3. So it is 1 minus to n plus 1 by 2/3. Therefore yn equal to 3 by 2 . So we can write this equation as yn equal to 3 to 2 minus half into 1/3 of n. So this is the step response of the system. This is step response of system. Now the next problem in this type, last problem. Now this problem was also asked for 4 marks in exam. Determine following whether following LTI system described by impulse response, h of t equal to e raised to minus t u of t plus 1 is stable and casual. So first, what is given? Given is h of t is equal to e raised to minus t u of t plus 1. So for stability, first condition of stability is what is the condition of stability? It is s is equal to minus infinity to infinity h of t dt less than infinity. So the given equation contain, we write here, given equation contain u of t plus 1. So limits of integration will be from minus 1 to infinity. So s is equal to minus 1 to infinity e raised to minus t dt. It is e raised to minus t by minus 1 to infinity. So we solve these and we get the answer 0.367. Now since s is less than infinity, it is stable system. The system is stable. Now for causality, the given equation contain u of t plus 1, so it is advanced, or we can say future term, so it is non-causal system. So this problem was asked for the 4 marks in exam. Thank you.